This is Mrs. Weethy back for Unit 1 Video Lesson 9. And in this lesson we're going to take a look at the units for measuring heat flow. Heat flow is measured in two common units, and those units are the calorie and the joule. A calorie is defined as the quantity of heat that is needed to raise the temperature of 1 gram of pure water 1 degree Celsius. Now, the word calorie is written with a small c, except when you're referring to the energy that is contained in food. The dietary calorie is written with a capital C. So the heat energy calorie, lowercase c, dietary calorie, capital C. 1 dietary calorie is equal to 1 kilocalorie, or 1,000 calories, heat calories, energy calories. And we have conversions that we can use to convert from one to another. 1 dietary calorie is equal to 1 kilocalorie, which is equal to 1,000 calories, which is the heat energy calorie. Now, a joule, on the other hand, is the SI unit of energy. SI is the International System of Units. It's a standard-based system that's used throughout the world. So anytime you see a capital J, refers to joule and is the SI energy unit. Now, 1 joule of heat raises the temperature of 1 gram of pure water 0.2390 degrees Celsius. You can convert between calories and joules using this relationship. 1 joule is equal to 0.2390 calorie, or 4.184 joules is equal to 1 calorie. Now, in coming problems, heat problems, energy problems, we're going to be using these relationships to convert between these units. Now, what factors does the heat capacity of an object depend upon? Well, first of all, let's define heat capacity. That is the amount of heat needed to increase the temperature of an object exactly 1 degree Celsius. And we talked about heat capacity before when we calculated the heat or the temperature of the Bunsen burner flame. So the heat capacity was that lowercase c that we used in that equation. Q is equal to mc delta T was the equation that we used. So the heat capacity of an object depends on both its mass and its chemical composition. So if we take a look at this, the greater the mass of the object, the greater its heat capacity. So a massive steel cable, as we see here in the bridge, requires more heat to raise its temperature by 1 degree Celsius than a steel nail does, as you have less mass. The specific heat capacity, or just simply called specific heat of a substance, is the amount of heat it takes to raise the temperature of 1 gram of that substance by 1 degree Celsius. So take a look at this. These are common specific heats. Specific heats of common substances. Look at water. Liquid water has a very high specific heat compared to that of silver. And why is that? The water molecules are held together by hydrogen bonding. And so with the hydrogen bonding, it's a very strong interaction between the water molecules, and it requires a lot of heat energy to break those hydrogen bonds in order to heat the water up and get it into the vapor phase. So water has a very high specific heat compared to the other substances. Metals generally have low specific heats, and that's because metals stand alone as individual atoms, and they have weak interactions compared to those of the water molecules. So the specific heat of water takes a lot of heat to raise that temperature of water because of those hydrogen bonds. But on the other hand, it also releases a lot of heat as it cools. So that's why when you go to take a bite of hot apple pie, you can get burnt. And the reason for that is the filling of the hot apple pie is made up of mostly water. So as that water starts cooling down, it gives off a lot of heat. And so when you go to eat that hot apple pie, you have to be careful not to burn your tongue. Okay, so that is our video lesson number 9. This is Mrs. Wheathy. So long for now.